This is a worked example on how to find the value of an inverse trig function. In this specific example, we're working with arcsine of -1. So what I generally recommend to do in these problems is set this equal to some unknown value, and let's turn this into an equation that we can solve. I will pick theta because we work a lot with theta in trigonometry. So now I have this as an equation, and I'm now equipped with the ability to use inverse functions with sine, cosine, arcsine, cosine. And so I'm going to take to both sides of the equation just the sine function. So I'm taking the sine of both sides, and from a property of inverse functions, these two are going to kind of cancel each other out or undo each other, and we're now left with this equation, which is a lot easier to solve. I don't have a unit circle, but if we look really quickly, well, when is the y value of the unit circle -1? Well, that's going to happen at this point right down here. Now, you want to be just a little bit careful, because you might look at this and say, okay, well, that's going to occur at 3 pi over 2. So theta equals 3 pi over 2. And in the context of this equation, that is correct. However, we're looking for the solution to this equation. And you need to be careful, because if you recall, the domain of arcsine, or I'm sorry, the range of arcsine, what values arcsine can output, is restricted to negative pi over 2 and positive pi over 2. So that's a range restriction on our function. And 3 pi over 2 is outside of that range. So how do we fix this? Well, what we have to do instead is we have to find a different angle that meets 3 pi over 2 at the same point, but that's actually in our arcsine function. So on our unit circle, instead of going, 3 pi over 2 is down here. Instead of moving around the circle in this direction, what we're instead going to do is we're going to move in this direction, which makes our radian measure negative, but stays in the range of arcsine. So instead, we will say that theta equals negative pi over 2, and this is the correct solution because it stays in the domain of arcsine. So this general formula of, converting this into a sine equation is all well and good. Just make sure you're not forgetting to take care of the domain restriction and the range restriction on the inverse functions. But that is a general method for how you can evaluate arcsine.